Let's take a look at lesson 4, starting with the distributive property. First concept, we all know the distributive property. If you have something inside the parentheses, just a refresher, and something outside the parentheses, say it's 3 times 4 plus 5. Yes, you could add that inside, or you could distribute the 3 to multiply by the 4 and 5. I like to draw little arrows. So 3 times 4 is 12. 3 times 5, use a sign in the middle, plus 3 times 5, 15. So your answer would be 27. Or if you solved it to where you solved inside first, 4 plus 5, 9, times 3, also 27. But that's just a refresher on the distributive property. Now we're going to use that with some variables. So example 4.1 says expand. And it gives us this expression right here. What we're going to need to do is simply distribute the 4a squared over b to each isolated term. So we start with the 4a squared being multiplied by the b negative squared. Well, if you remember, when you multiply variable exponents, you add them together if they are the same. There's an a and a b. So they cannot be added together. So we are left with 4a squared b negative squared. You simply combine it. It's that easy. Then we do the bottom. So there's the numerator. Then you do the bottom, b times a to the fourth. Now I'm going to put it in alphabetical order just because I like it that way. More organized, easier to see. So I have a to the fourth times b. That's the same as b times a to the fourth. So we just did the first part of the expression. Now we got to distribute it to the next part. Now something that can trip you up here is this subtraction sign. When you have the subtraction sign, you do have to make this negative. So therefore, when I do 4a squared combined with 3ba, we have negative 4. I'm going to put all the common variables together. 4 times 3 a squared a b. And then you simply simplify. I'm going to go ahead and simplify that at this point. So 4 times 3 is 12. A squared times a. Remember, if you have two variables, two exponents of the same variable multiplied, you add them together. So 2 plus 1 is 3. So a cubed. And I'm just going to move this b over here. B. So we just did the top. Now we do the bottom. Have the negative sign already. It's already there. A squared times b. I'm going to write it in that order. Now from this point, like we did, I believe it was in the last lesson, we want to go ahead and make all the exponents that are negative, we want to combine all of the exponents, the variables, we want to combine all of the same variables. So a squared and a to the fourth. These are the same variable. So if I move this to the top, it would become a to the negative fourth. I know that's probably cluttered on screen, but I'm going to move all these over here and then I'm going to simplify it. It would look like this. 4a squared a negative 4, because we moved this to the top, b negative squared, and since we moved b to the positive 1 at the top, b negative 1. We can go ahead and simplify. 2 minus 4, negative 2. negative squared, negative 2, negative 1, b negative cubed. So 4a negative squared, b negative cubed is that part of the expression simplified. Then we have minus, I'm going to solve up here and then simplify, 12a cubed over a squared. Now once you get good at it, I'm just going to go ahead and show you a quick way that I do it. All you really have to do is actually subtract the top from the bottom. 3 minus 2. So if I did 3 minus 2, that would simply be a. So it'd be 12a, b divided by b crosses out because it's 1. So you're just left with 12a. Just to prove this real quick, if I put that on top, it'd be a cubed, a negative squared, so it'd subtract to be 1. But you can actually always subtract the numerator minus the denominator for the variables. So we would be left with, we already did that, minus 12a. This would be fine. If you wanted to make it positive exponents, you could write it as 4. I'm going to erase this. 4 over a squared b cubed minus 12a. You could write it that way as well. But yeah, hopefully that makes sense. We'll do one more here, and I'll show you the subtracting variable way that I just did. Example 4.2. Distribute. Here, I'm going to work this one a little bit faster. The b to the 0 power, that cancels because that's 1. So anytime we multiply 1 by whatever, it's going to be the same thing. So unnecessary to distribute that. So a negative cubed multiplied all here. Negative 3 and 2, those added together is negative 1. So a negative 1, bc, just did that, over, well, 1 plus 2, when we distribute, is c cubed. Minus, once again, going a little faster on this one. Distribute over here, minus a 3, a negative cubed, a negative squared adds up to be a to the negative 5th, divided by b negative squared c. So what we have here is, let's see, we got two terms. I'm going to show you how I subtract. So imagine c with a little 1. If I subtract 1, these are our only like terms within this expression here. 1 minus 3 would be negative 2. So if I had, we already got this part, c to the first, you simply have to subtract there, and that would become c negative 2. If you need to move it to see it, no pun intended, you could do that. And then you'd see the 1 minus 3 negative 2. Or if you just needed to look at it from this angle, 1 minus 3 negative 2 if you're moving it to the numerator. So there's that term, minus 3a negative 5th over b squared negative squared c. The a's do not have the same exponent, so we know that they will not combine. But if I wanted to make it positive exponents, it would look like this: b over ac squared minus 3b squared a to the 5th c. So you can do that in your head once you get good at it, or you can just look at it and see how it works. But that is distributing variables. Moving on to 4b, solutions of equations. These are a couple easier concepts than the last one. The last one's just a little more work. All this is just solving for equations where you have multiple, x's in one equation. So what you want to do is start with the order of operations. So you got parentheses. Well, you can't add anything in the parentheses. None of those are like terms. What's next? Parentheses, exponents, don't have any exponents, multiplication. Is there any multiplication? Well, yes, actually there is. Actually, when we have this negative, it is like distributing a -1 to both of the terms inside the parentheses. So what we would actually have, this is what confuses a lot of people, you would actually have 12 minus 2x minus 5, because -1 times 2x, -2x, -1 times 5, -5. So that would be this side of the equation. So we got the left side of the equation. Now let's simplify the right side of the equation, see if we can get rid of the parentheses. Imagine a little 1. It's a positive, so these are actually going to stay the same. -2 plus 1 times x, 1 times -3, and that would be the right side of the equation. So now we've got it simplified here. Now it's up to you how you want to solve it. I'm going to go ahead and simplify both sides. So I'm going to start on this side. Can anything be simplified as a like term? Well, 12 and 5, or -5, like terms. So 12 minus 5, 7, minus 2x is left. -2 minus 3, -5, plus x. And now it's up to you how you want to solve. I'm going to combine the x's. I'm going to add the 2x on this side. And if you do it to this side, have to do it to that side. This cancels out because -2 plus 2x is 0. X plus 2x, 3x. Running out of room here. But you have 7 equals -5 plus 3x. You would add the 5. I'm not going to be able to show it, I'm running out of room, but add the 5 to both sides. So you would have 5 plus 7, 12 equals 3x. Divide by 3, and you would get 4 equals x. And so 4 would equal x, and that's all you need. So that would be the answer in example 4.3. Now let's do example 4.4. A little more stuff right here. We've got some fractions to make it look intimidating. First, order of operations, parentheses. Can you solve inside of it? No, these are not like terms. No, these are not like terms. No exponents. Multiplication. Yes, we can multiply because we can distribute. So I'm going to distribute 3 times 5 over 6 minus 3, negative, minus 3 times 5 over 3x. Yeah. Go ahead and solve for this. This can cancel. 3 goes into 3 once, and 3 goes into 6 twice. So we're left, that's just 1, 5 over 2. 5 over 2. Over here, the 3's can cancel, and you're left with -5x. So we just solved the left side of the equation. I'm going to go ahead and erase this. Hopefully you saw that. If not, just rewind the video. I'm going to move this up here. So 5 over 2 minus 5x. And then we do this side. We have to multiply. Now this can get tricky because you got a negative sign. All right. Just like we did on the last one, we're going to, a couple before, I guess. No, on the last one. Multiply the -1 to both. So -1 times -1/2 is +1/2, because 2 negatives make a positive. -1 times +x would be a negative x. So therefore, minus x. And so now we have the right side of the equation, and easy peasy. We don't have any like terms on either side, so let's go ahead and combine. I'm gonna add 5x to both sides. Cross out. Negative 1 plus 5 is 4. 4x equals, oh, no, sorry, 4x plus 1/2 equals 5/2. And then we're trying to get x by itself, so subtract 1/2. 5/2 minus 1/2 is 4/2. Go Chinese style, move it to the left. 5/2 minus 1/2 is 4/2 equals 4x. Oop. 4 divided by 2, hopefully we know that math by Algebra 2, that is 2. 2 equals 4x. To get x by itself, they're being multiplied, 4 and x, so we have to divide by the 4 on both sides. So x equals 2/4. Let's go ahead and reduce that to 1/2. X equals 1/2. And that is how you do solution of equations. The last part on lesson 4, moving to 4C, is simply the principle of when you change sides, you have to change the sign. So to show what that means, we'll look at example 4.5. All right, 4.5, it says solve for x. So we're trying to get x by itself. So all that means is we need to move the negative 2 over here. So just like the concept says, if we want to change the negative 2 to the right side from the left side, we need to change the sign. So add 2, add 2, see, negative 2, positive 2, now those cancel to be 0. 7 plus 2 is 9, so x, it equals 9, but we have x by itself. And that's the whole purpose. That's all you're trying to do here. Let's do 4.6. This should be really easy. We're solving for p. Solving for p. So we just need to get everything on this side. So to get the negative 3x over here, add it. And those cross out. To get the 4 over here, it's being added. So we need to change the sign to the opposite. Opposite of addition, subtraction. And so you're left with p equals 7y plus 3x minus 4. Bada bing, bada boom. There's your answer. That's all you got to do. And then solve for y. We'll do it really quick. Getting y by itself, the only thing is y has something attached, the 3 attached to it. Add the 2x. Changing the signs. Change the sides. Subtract the 5 on both sides. Now 0 minus 5 is negative 5. So you have 2x minus 5 equals 3y. That's where we're left. Now how do we get y by itself when it's being multiplied by 3? Simply do the opposite of multiplication. Opposite of multiplication is division. So you divide by 3. You could write it like that and have your answer as y equals 2x minus 5 over 3. And that would be perfectly fine. Or you could actually write it like, let's go back one step. You could actually write it like that and have y equals 2/3 x minus 5/3. Those would be the same thing, either one. Either or would work. Just know how to do this for in the future because you may be able to solve some of those expressions further. But that is all that lesson 4 is.